Hey there, mathematicians! It's Justin again. Today, we're diving deeper into fractions, focusing on multiplying and dividing. Let's get into it. Last Monday, I bought half a loaf of bread from a bakery nearby and ate 3/4 of it. I'm curious to know how much of a whole loaf I ate. I know you can help me. Pause here to jot down your thoughts about how we might determine how much of a whole loaf of bread I ate. Maybe you used a diagram to help you visualize the problem. They're great for problems like this. Or maybe you tried a different method. There's often more than one way to solve a problem. Let's keep investigating so we can learn a way to solve this one. By the end of this lesson, you'll be able to demonstrate how to multiply and divide fractions. You'll also be able to use multiplication and division of fractions to solve real-world problems. What are we waiting for? Let's go! Let's begin with a review of multiplying fractions. I bought half a loaf of bread and ate 3/4 of it. How much of a whole loaf did I eat? To find out, we multiply. Multiplying fractions helps us find a part of a part. In this case, 3/4 of 1/2. When multiplying fractions, we multiply the numerators, then multiply the denominators, and, if necessary, simplify. 3 times 1 equals 3, and 4 times 2 equals 8. I ate 3/8 of a loaf of bread. Now, if I eat 3/8 of a loaf every day for 5 days, how many total loaves will I have eaten? Again, we use multiplication here. 5 times 3/8. When multiplying a fraction by a whole number, like 5, we need to write 5 in fraction form, 5 over 1. We can rewrite 5 like this because this fraction symbol actually stands for division, and any value divided by 1 equals itself. Now we can multiply. Pause here while you solve this equation. Multiply the numerators, 5 times 3, and that equals 15. Then we multiply the denominators. 1 times 8 equals 8. Now we simplify. 15/8 is an improper fraction, so we need to regroup and convert this improper fraction into a mixed number. 8 goes into 15 one time, with 7 left over. Over the course of 5 days, I ate 1 7/8 loaves of bread. If I intend to eat almost 2 loaves of bread each week, I should probably learn to bake my own at home. Let's say the recipe calls for 6 cups of flour and my measuring scoop holds 2 cups. How many scoops of flour will I need? To figure this out, we divide. 6 divided by 2 is 3. I need 3 2-cup scoops of flour. But what if my measuring scoop holds 1/3 of a cup? Then how many scoops of flour do I need? We can use the same process. 6 divided by 1/3. Dividing fractions helps us to find how many of one fraction will fit into another value. This division problem looks like a super funky fraction. There must be a way to make this a little easier to work with. Maybe we can find a way to make the denominator equal 1. Remember, any value divided by 1 equals itself. So this would allow us to just focus on the numerator to solve. But how can we change 1/3 into 1. A fraction of 1. If I multiply this 1 by 3 and the 3 by 1, I get 3 over 3, a fraction of 1. Notice how 1/3 and 3 over 1 are flipped around? These fractions are called reciprocals, inverse or flipped fractions. Multiplying a fraction by its reciprocal always results in a fraction of 1 or just 1. Like with most of our fraction work, whatever we do to one part, we must also do it to the other to keep things equivalent. If we multiply this bottom part by 3 over 1, then we need to do the same to the top. Now we have 6 times 3 over 1 all over 1. Anything over 1 equals itself, so we can focus on solving what's in the numerator of this division problem. Let's rewrite this 6 in fraction form so we can multiply across. 6 times 3 equals 18, and 1 times 1 equals 1. 18 over 1 equals 18. I need 18 of the 1/3 scoops to get 6 cups of flour. Let's try another. Solve 4/7 divided by 2/3. We can rewrite this as a fraction, 4/7 divided by 2/3, or 4/7 over 2/3. We want the denominator to be 1, so we need to multiply 2/3 by its reciprocal. Pause here while you find the reciprocal of 2/3. The reciprocal of 2/3 is 3 over 2. If we multiply our denominator by 3 over 2, then we also need to multiply our numerator by 3 over 2. 2/3 times 3 over 2 gives us 6 over 6, which equals 1. Anything over 1 equals itself, so we can focus on this top part. 4/7 times 3 over 2. Start with the numerators. 4 times 3 equals 12. And then the denominators. 7 times 2 equals 14. And finally, simplify. The greatest common factor of 12 and 14 is 2, so we'll divide them both by 2 to get our final answer, 6/7. Great work! Division. Multiplying by the reciprocal. You may have noticed that each time we multiplied the top and bottom of these division problems by the denominator's reciprocal, the denominators became 1, and we could focus on just the numerators. Whenever we divide fractions, we can flip the second fraction and just multiply by the reciprocal. This allows us to quickly get a denominator of 1 and just focus on the numerator. We aren't skipping any steps, we just aren't writing it all out every time. Let's try it with 2/5 divided by 3/4. We need to rewrite this equation with multiplication of the reciprocal of 3/4. Pause here while you try it yourself. 3/4 reciprocal is 4 over 3. So our equation becomes 2/5 times 4/3. 2 times 4 equals 8, and 5 times 3 equals 15. This fraction is already in its simplest form, so 8/15 is our answer. Thanks to your hard work today, I learned that I need to buy more measuring cups. And you learned that fractions are multiplied by multiplying the numerators and denominators. And any value with a denominator of 1 equals itself. And dividing by a fraction is the same as multiplying by its reciprocal. In our next lesson, we'll be learning how to multiply and divide mixed numbers. Be sure to complete the practice questions and extension activities to help you prepare. Keep crunching those numbers, mathematicians, and I'll see you next time.
Hey, hey.